This gearbox was just a lump of metal a few months ago, sitting in a corner of my garage, gathering dust. In my last video, I cut ties with the world's most boring car by installing an open inverter board and made it spin. Eventually this motor is going into something far less sensible, but before it can move a car, I need to control it properly. That Prius open inverter board was designed by Damien Maguire, with Johannes Hübner doing the software side. Brilliant work, and exactly why I want to make my own version, at least on the electronic side. Why? Because I wanted to actually understand how this whole thing works. And the only way I know how to understand it is to build it. Get it badly wrong and then slowly work out why. Will it work? Probably not for the first time. Or the second for that matter. But you won't learn anything from version that works. So let's build it. I've made changes to almost every part of this design, but let's start with the Wi-Fi interface, partly because it's where most of my pain lived, and partly because it's the bit you actually see. The original design uses an ESP32-S3 for the Wi-Fi web interface. It mostly works, but I struggle to connect to it sometimes. Programming is fiddly enough to test my patience, so I'm switching to the ESP32-S3. It has a built-in USB, 2 serial ports and considerably more headroom to play with. Will this be a straight swap? Almost certainly not. I will need to refactor ESP32 code, which thankfully available from Johannes Hübner GitHub. The sensible approach here would be to get an ESP32-S3 development board, test it alongside the original Prius inverter, so naturally instead I designed the board first in KiCad. Full code refactor I left for the future Ed. I'm sure he won't mind. I do at least want to confirm the ESP32-S3 will talk to the open inverter board at all. Well, first I think I need to tidy up my battery cells into one proper module. One unit, manageable, not messy, pile of cells held together by hope and electrical tape. Here's the problem. These PCB holders I bought from AliExpress are designed to be connected in parallel, stacked like at multi-decker buses, which is great if you want more capacity at the same voltage. I want the opposite. I need them in series to get up to around 86 to 90 volts. The obvious solution would be just to flip the second board upside down, except that gets me one connection right and the other shorting the battery directly, so no. And then I noticed the actual solution was staring me right in the face. Metal pillars, the kind that holds the board apart in a stack. I could use those as a connections. Not at every corner though, only specific ones. Because here's the clever bit. One corner of each board is completely isolated from the cells. Another corner is connected through a fuse, so if I remove the fuse and flip the board upside down, the pillars line up positive to negative. Series connection. No short circuit, no drama. I got to work, removed the fuses, connected the metal pillars where possible. The first version was great apart from the small detail that the bottom cells kept falling out, so I took it apart, redid it again. And then I noticed I'd forgotten to remove the fuse on another layer, so second disassembly. Right, let me present the final prototype of the assembled battery module. Time to test the ESP32-S3 connection, but first I need to move capacitor. As far as I can tell, I only need those two connectors for the inverter part. These other ones only feed the DC to DC converter, which I'm not using. How do I know? I read the entire Oak Ridge National Lab research paper on Prius power control unit, all 80 pages. And by read, I mean I looked at the diagrams and guessed the rest. Let's see if it works. Throttle pressed and motor spins, excellent, as I expected. Now I have a full access to the open inverter board, which means I can finally hook up the development board and find out if the ESP32-S3 will actually talk to it. Here is the preliminary test prototype wired up. I thought it would be cool to see how it works. And let me tell you, it does not. Every time I try to run web interface, connection error, frustrating buffering, and entirely without obvious explanation. And then, completely by accident, I forgot to power the development board from Prius board, powered it separately afterwards instead, work perfectly.
Turns out timing is important and not just in comedy.
I tested it many times, every time ESP initialized after the Prius board. It worked flawlessly.
Technically, there is an explanation involving boot sequences and signal states, but technically, I'm too lazy to explain it. Right, ESP32-S3 talks to the Open Inverter board. Confidence level approaching adequate, which means it's time to actually manufacture this thing.
And this is where PCBWay comes in. Who are sponsoring this video, by the way? I was going to use them regardless, because I think they are really the best option.
Here's the part that genuinely makes my life easier. KiCad has a PCBWay plugin that turns the whole submission process into basically one button press. Generate the files, upload, done. No fiddling with Gerber, no wondering if I've sent the right file. Submission goes off, they review it, come back fast if something is wrong, and once it's accepted, you can watch every stage of manufacture happen, which is weirdly satisfying, I have to say.
A few weeks had passed, and here it is.
The quality of this board is excellent, and it's really exceeded my expectation. Let's have a look and inspect it a bit closer. And here's the bit that actually surprised me the most. The JST connector for PWM signal was already soldered on. On my last build, I had to find one connector and solder it by hand. This time, PCBWay just found the right connector, didn't have to ask, which means the board is now more completely assembled than anything else I've touched in this video.
With the board finally in my hands, I got straight into the usual routine. Test the supply voltages. Program the STM32 controller. Confirm nothing about to release a magic smoke. All of which went suspiciously smoothly, which on this project is usually a warning sign. Then I moved on to programming the web interface. And that's where things started to go wrong.
The first thing it did when I plugged it in, it's crash. Non-ending loop out of the box, before any firmware was even written yet.
So I had to manually hold on the boot pin, force it into download mode, and completely erase the flash before I could even talk to it. Fine, okay, moving on. This is my favorite bit. It would work perfectly when I plugged it into my laptop. Wi-Fi came up, everything happy. Very exciting. Unplug it, run it standalone, nothing. Turns out there was a part in the code that was just sitting there, waiting for USB connection that was never coming. And then I had indicator LEDs on UART lines to show activity, which is perfectly reasonable thing to do. Except at 921,600 baud rate, they were loading the signal down just enough to corrupt everything. So I was getting connection error.
LEDs added to show that this thing is working, making it not working. I would say this is almost funny if I didn't have to work till midnight to figure that one out.
I removed them at 1 AM with soldering iron and it worked first try.
As they say, every cloud has a silver lining. And silver lining in all this, as I wired GPIO 21 as a status indicator.
It blinks when Wi-Fi hotspot is on, goes solid when something connects to it. It works, it blinks. Look, I made that blink correctly. Youppi!
And now, with the board past all its basic bench tests, it's time to move this game to the Prius Inverter itself. So this is actually a little bit a nervy moment for me, because this is the first time I'm fitting this board. So let's see how it goes on. Wow, this is almost perfect.
After that, I fitted the remaining bits, powered up the inverter, connected the web interface, and set it into a manual mode. This is the moment where I get to set the parameters that enable the PWM signal, the actual switching, the thing the whole board exists to do.
Yay, we are getting PWM. I got PWM signal working on the first try. And this is our signal. We're measuring it on that test point here, and I'm so chuffed.
Wait.
Can you decode that? Probably not, we don't have an encoder. But of course the whole point of this is the control rotation.
And the first step towards that is getting encoder connected and confirming it actually works. I sorted the encoder out in my previous video, and crucially I kept the same pinout on the connector so I could reuse the existing wiring harness. No recrimping, no rewiring, just plug it in and start the inverter. Lovely. So I fired up the inverter from the web interface and off we go to build the plot. That signal looks very strange. Could it be that I forgot to set the right encoder type? No. Could it be that the inverter had to be stopped before the encoder type could be changed? Again, no. Could it be that the refresh button had to be disabled before I could change the type? No. Could it be that the inverter had to be stopped, then restarted and the plot restarted as well? Oh yes, it could. And there it is, the encoder readings from 0 to 360. It works. This is something I could have tested before I checked the encoder, or resolver if we are to use its correct name. But better later than never, I would say. Next up, I want to test the motor rotation in open loop mode, which means just applying the parameters and letting it spin without actually measuring the rotation angle. So at this point I need to connect my battery. I'm doing a manual pre-charge with a switch. Let's try to rotate. Oh no, I left the bulb connected. Let me bypass the bulb with a switch. There we go. Okay, now we try. Slip spin 5 and 50 amps nominal. And I'm getting a knocking sound. I'm guessing my battery is now slowly losing charge, which isn't ideal. So I'll drop to 3 and 50. And here it is, rotation clean now. It spins. We are on the final straight now.
And I'm hoping to get there a bit faster.
By leaning on the parameters I found from my previous Open Inverter build. Why reinvent the wheel when the past me already did the hard bit? This is the step where we update to the FOC version of the firmware, field-oriented control. Is the motor control with the feedback, which is the whole reason we needed a working encoder in the first place. But this time, no wires.
I'm going to flash the FOC firmware over the air. Yes, you heard me right. Over the air update.
Here we go, install from file and update complete. No cables, no fuss, easy doing. Let me check, and yes, FOC version 5.39, excellent.
And now I'm going to save myself an enormous amount of time.
By simply importing the parameters file I saved when I finished tuning my old board. Here we go, import complete. Now I need to save the parameters to flash, so next time I power up they will still be there. Refresh the web page and there it is. My sync-offs value has made it straight into the new board.
Which means I can now test the motor in full working mode, the real thing.
So I connected the battery, flicked the forward switch and powered on my Prius board. And right on, that customary pre-charge contactor sound. Lovely. Now I just need to press the start button and we are ready to try the throttle pedal. I press the button. Silence. Complete silence. And when I say silence, I mean no main contactor sound at all. Nothing. I measured the test point for the start button signal. And as I suspected, there is no voltage present when the button is engaged. Now, this is a momentary switch. It only makes contact while it's actually being pressed. So the signal should appear the moment I push it, but it wasn't. So let's go back to the beginning and check the source voltage is ever present on the connector for this button. Check, voltage is there. Check it right on the ribbon cable going to the Prius board. Also present, which makes this a complete mystery. The voltage is there, it's arriving to the board and the board is ignoring it. And then it hit me. Maybe the signal is present, it's just present on the wrong pin. Remember earlier when I said,
and crucially I kept the same pinout on the connector.
And of course it isn't. Yours truly, for reason lost to history, swapped the start button and the cruise signals. So the start signal is there, alive and well. It's just not on the pin my Prius board is expecting it to be. Easy as fixed, rewire the amp seal connector and reroute the start signal to pin 7. Where the board actually expects it. Quick rewiring job, and yes, it works. Here's how I know. Power it up, pre-charge contactor kicks in, press start, main contactor engages, clunk. And I can confirm it in the inverter status on the web interface too. Turns out the bug was me. Again. Anyway, I was thrilled. My motor will be spinning again. But my smile lasted about 4 seconds. I pressed the throttle pedal, the motor started to turn, and then clunk, and then nothing. Some further checks revealed the battery voltage was very low. Further inspection showed why. The fuse on top module had been blown. So I did what any serious engineer would do. I soldered copper wire on top of the fuse to bypass it. Tried it again. Same result. Give me a day or two to figure out this one. Okay, I think I've got this. When I was making changes to my board, I swapped the current sensor connector for a different type. I have a newer inverter type, so I picked the same connector Toyota used on my model to match the wiring harness. Except I assumed the pin numbering would be in the same order as the old connector. They are both GST parts. After all, one is vertical, another one is horizontal. How different could they be? Completely different. That's how different. So the current sensor signals for MG2 were routed wrong. My first plan was to cut the tracks and modify the board, but there was too much rewiring for the power tracks to make that sane. So instead, a second connector mounted on top of existing one with its pins wired to the correct places on the PCB. Right, now I'm just going to be brave and run the motor straight away without checking the current sensor signals first. Everything connected and it's spinning. I got there in the end. I'm completely exhausted and happier than I ever been in months. There is a very specific feeling when something you designed, built, broke and fixed finally works. And I don't know where else to get it.